In this session, we will discuss about the metric server and horizontal pod autoscaling. And in last session, we did about the resource limit and quality of service class concepts. So we applied the resource limit and quality of service class concept. So based on these resource consumption on different pods, we can make decision of scaling up our application when the load will come. So by default, if we look into our cluster, this is our Kubernetes cluster, and if we do a kubectl get nodes, it's good up and running. And if I do a kubectl top node, so it is giving me the error metric API is not available. Actually, metric server is a Kubernetes application, designed application that can talk with the C group that is responsible to apply the limits on the different namespaces. So metric server will pull the current usage of worker nodes and the pod. So we can run top nodes, top pods, these commands. So, but so far we don't have any metric server. So first of all, we will set up the metric server. We will enable this. Then we will be able to see how much CPU and RAM is consumed by which pod and which node. So if I go to the documentation, so the Kubernetes GitHub repository is providing this manifest. If you explore this, there are a lot of useful manifest available, but under the metric server release latest download, the latest metric server manifest is available. So let me just do a download under the download this manifest. This components.yml is downloaded. And if I open this manifest, so this manifest contain multiple resources, just like a service account is created. So far, we have not covered this topic. So just think about it is creating multiple resources. It is creating cluster role. We have not discussed this so far, but it is creating this resource, cluster role. We go down, role binding, cluster role binding, cluster role binding, and then it's creating a service to expose it to the others externally, I think within the cluster. And this is the deployment it's trying to do. And in the deployment, this is the selector, label, rollout strategy. These are the arguments. And if we go down in the container section, and this is the resource limit, how much max this deployment will be able to take the resources. And where is the image part? Yeah, this is the image, and it will pull this image from this public repository. So the whole magic is inside this image. And this image, this container will run with this name of the container is not mentioned, but this container will run based on, this is the metric server name of the container. It will run based on this image, and this image will use all the above resources we have created, and it will talk with the IPA server within the cluster, and it will fetch the resources consumed and will show us on the command line. So this is a tool designed by the Kubernetes community. So we just have to apply this and it will create all these resources in which namespace. If we look into the namespace part, so of this deployment, so we can see this deployment is going under kube system. So rest of all resources are also going under kube system, and you can see this. Okay. So you can see this namespace kube system. So all the resources will go by default under the kube system namespace. If you want to create a separate namespace for this metric server, this is also possible. But it's good all the component related to management of the Kubernetes cluster must be under the kube system namespace. So let me quickly apply this manifest. Let's see what happened. kubectl apply -f. So it creates all the resources, and if I look into the kubectl get deploy, in the kube system namespace. So metric server deployment is trying to create a one replica set. In that manifest, you can see the deployment is based on only one replica set. So only one pod is good to fetch the resources from the cluster. It is trying to bring up some pod, but I think it will have some issue. This metric server pod is running under this deployment, and if I look into why 0 out of 1 mean the container, one container is inside this pod and that is not ready. So if I do a kubectl describe pod in the namespace kube system, so you can see this assigned scalar to the, and the image is pulled, everything is good, container started, but get into unhealthy state, readiness probe, HTTP probe. So actually this is the some certificate related issue. This is some known issue. So the workaround is we can make our cluster communication with this metric server without HTTPS based communication. So it's the internal configuration. So for that workaround, we need to add under the argument section this part, kubelet-insecure-tls is equal to true. So let me just go to this manifest and this deployment part. This deployment part, this is the argument section. And here I just need to add this part, and again, I believe reapply will work. You can see all these resources are unchanged and only deployment is configured with the new value. So let me now check this pod. It's trying to create another metric server. And this time 2 pods are running. The old one should be deleted automatically, or I can do kubectl delete these both pod into the kube system namespace forcefully. So one is already deleted. So describe pod. Yes, it is now started. It is started 0 out of 1. It is still trying to start some service, I think, but it's in healthy state. That error message is gone. So now if I do kubectl top node, still API server is not up. Okay, let me just do one thing. kubectl delete this whole manifest, whatever I is created, delete this, and again apply this with the new values. So maybe this will be affected by some other API resource created. So get pod, and it is still trying to yes, it is up now. So now when I use top command, the API server is up, and if I do a top pod, the default namespace only one name. If I do a -a, all the namespace is pod. So I can fetch the information of all the pod, how much CPU millicore is consumed by which pod, and how much memory is consumed. So this actually, when I query this request to my API server, so API server talk with the metric server. The metric server responded to API server that these resources are in use. So now our metric server is up and running. When you will set up the Kubernetes cluster in cloud, it will be automatically be deployed by your cloud provider. So far we are doing this exercise on our on-prem cluster. That's why we did this manually. So what's next? The metric server is ready. So based on this metric server, we can do the horizontal pod autoscaling. So what is horizontal pod autoscaling? We go to the documentation, type here HPA. Sorry, HPA. So horizontal pod autoscaling. In Kubernetes, horizontal pod autoscaler automatically update a workload resource such as deployment and stateful cell with the aim of automatically scaling the workload to match demand. I mean, you cannot scale up the daemon set, but you can scale up the deployment and stateful set. Because daemon set concept is to just set up one pod on each worker node. So whatever application is running under this stateful set or deployment, and when the CPU or memory load will expand, increase, then each API resource can make a decision of scaling. Just like if we have a deployment and we did the scaling with the command line, if you remember. So that same thing will be done by HPA, horizontal pod autoscaler. If we do a kubectl API resources, grab HP horizontal pod autoscaler. So this is the resource we are going to use for this purpose. So first of all, I need to deploy an application in the form of deployment, not as a pod. It's not controlling the pod. It's only, or scaling is only happening with deployment or stateful set. So wherever we are defining the replicas, so those number of replicas will be increasing or decreasing. So I am going to use my this replica deployment we use. Let me see what type of images we use in this one. So replica, let me change this replica to 1. And based on the load, it will automatically increase. And the second thing is this resource limit is mandatory, because when you are going to do the auto scaling, so you cannot do this without a resource limit. So here I will do limit for resource. Just like yeah, resources, and I think indentation I need to let me check the indentation. Resources request and limit. Okay. So memory and CPU, I will limit to this amount, 500 millicore and 250 request. So this Tomcat application will run, and okay, this deployment is good in the dev namespace. Let me do this deployment. And kubectl get deploy hyphen and dev namespace. I can see one deployment is up and running with one pod. That pod is also good, up and running. Okay, great. So this pod cannot cross the memory limit of more than 500 megabyte and half more. So now what I need to do, let me create a service that a node port type of service that will make this application reachable for the end user. So for that reason, I will use kubectl expose deployment. Name of the deployment is this one, and in the dev namespace, and I know the type of this service. I want a node port, and the port within the container, I know it's 8080, so I would like to use the same. I like to use the same port. Okay, the target port is 8080. So dev namespace, node port, external request will come on 8080, and within the cluster request will come on 8080, and it will be forward to this 8080 within the container running inside this deployment. Okay, seems good. And kubectl get svc. So this is the default namespace, but in the dev namespace, let me delete this. This svc I already created for some other purpose. Get svc. Now we have in the dev namespace only one service. So since I am working directly from master node, so it's mean I can hit this IP, service IP, to validate the reachability of this pod. Yes, it is responding me, and this is the some default page responded by the Tomcat. So now from outside the cluster, I can go to my browser and I can type the IP of any my master or worker node. I can do this port, and this is a Tomcat 10.15 is up and running. I hit to worker node 2. It is also responding. This is some default page. Okay, now our application is reachable from external. Now I am accessing this application, and I will generate some load by some script. But before that, we have to make an understanding the horizontal pod autoscaler. So now we have to create an API resource of horizontal pod autoscaler with this deployment that will scale based on the load we will define. Okay. And if I go down to this documentation, I could get some manifest. Or I can create a manifest by the command line too. These are the parts of portion. I mean, the specific part of the manifest is defined, but not the complete manifest. No problem. So there is a command kubectl. I think HPA. No, I have a file here, manifest here. Yeah, the command is autoscale. kubectl autoscale -l. So autoscale will help you to create the HPA resource, but I will use my pre-configured manifest. This is the manifest I can use to autoscale, to define the autoscaling by using the HPA resource. So let me just create here some HPA Tomcat deployment. Okay, and here I will use Tomcat name. Oh, here. This is the kind horizontal pod autoscaler, and the name I defined Tomcat HPA. Okay. This is API variant kind on its deployment, on which deployment I want to do autoscaling, the name of the deployment, and the name of the deployment is kubectl get deploy. I created is PE Tomcat app. I will change this name with this one. And here I have to define the minimum. When the load will reduce and user is not accessing the application, the minimum number of pod running will be 1. And the max, when the load will come, it will increase to 10. We can set different number here, depends on our requirement. And then metric. Which metric values will decide the scaling or reducing the replica set, scaling up or reducing the replica set of this deployment. So it's based, I am defining here a resource of CPU and here a resource of memory. So type utilization, average utilization 50%. If the resource is it's consuming 50% memory, 50% memory and CPU, it will either CPU or RAM. It will create a new pod automatically. So now I have to do one more thing. It should be under the namespace, in the same namespace where our deployment is, and it's under the dev namespace. Okay. Let me apply this. So Tomcat HPA is working, this HPA working on this deployment, and we set a target to 50%. Right now it's unknown, mean the value of current usability usage of CPU and RAM is unknown for this HPA. It will fetch and minimum number of pod and maximum, and right now replica 0 bytes showing replica. I think it's trying to fetch the information. So let me check the status of deployment. It's 4 out of 6. Why it is increasing? I think the manifest I use for this deployment has one replica. So B Tomcat app, no, this is not the B Tomcat app is having. Oh, okay. It is doing auto scaling. Actually, I give the just a minute. Horizontal port. You can see its memory consumption is increasing. Main 250 or 500 millicore is very less for this Tomcat deployment. So Tomcat, it's a heavy application. So that's why our provided, if I do a kubectl get top pod hyphen and dev namespace, you can see this amount of CPU is consumed by this pod. This amount of CPU is consumed. So that's why the new pod are automatically created. So let me do one thing. Instead of using Tomcat, actually I don't have too much resources, so I will not use the Tomcat as an image. I will use some different image. Just kubectl get deploy. Kubectl get deploy and delete this deployment. Then delete this deployment and where was my deployment? But I used my deployment. And this was not a deployment I use. PA deployment I use. So in this one, I will change just the image with Nginx. Okay. The name of the application is Tomcat, but I can use here everywhere Nginx. B Nginx app. Okay. Okay, so now I have one pod up and running with the Nginx, and if I get my top pod. Metric not available yet. One pod is up and running. Okay, metric server so far not collected the information about this pod. So now it's provided. Now only 0 millicore CPU is consumed because Nginx is very simple application, very low weight. But Tomcat by default without any application is getting a high CPU. So for the Tomcat, at least 500 millicore is required. So it's consuming only 4 megabyte of RAM. So now if I do kubectl get HPA, and you can see only 1% CPU out of 50% and 103. I think this information is also old. So it is still getting value from the old deployment. So I think I need to delete this HPA and create again. And name of the deployment also need to change in HPA. Name of the deployment this time is Nginx. kubectl apply -f. Get HPA. Yes, this is now good. This is connected with the Nginx. So now it is responding that 6% of memory is used and 0% of CPU is used. Now I have to, and right now only one replica is ready. Max 10 can go based on the load. When I will increase the load to more than 50% or I will increase the RAM usage more than 50%, it will automatically scale up the deployment. So for that reason, I have for my Windows machine, I can access this service also. I will need to create again because the service for the external get svc-n then tab namespace ctl delete this service. This was our deployment. The node port will be exposed against this Nginx. If I get service, and if I do this, so this is reachable by the node port. It's mean I can send requests to any IP3 or to master or worker or to get this page. Now I have a script that will send too much request on this because I cannot generate request from this browser. I cannot create too much request from here. So I have a Python script I had a Python script, yes, load test.py. So if I go to this load test.py, this is a Python script, and show you the syntax of this. You don't need to understand the Python. I just pull this Python image from the internet that will run a script based on Python. It can be in PHP or in any other language too, but I had this. So in this Python script, I have to provide the IP where I want to send the request, name IP of the web server. So it's my worker node 1 I will send on this, or I can send on master node 2. Or I have to provide here the port number of the application. The port number is 30533. And rest of all script will do the magic of sending too much request on this port and IP. Okay, so we don't need to understand this Python script so far. I will share this Python script. You can get to this Python script in the description and link. So now from my command line, I have to check what Python version Python is installed. Okay, so I have Python, so I can run this script. Load test.py. So in this load test.py, it is sending requests to my cluster on that application. And if I get this HPA, you can see the CPU load is increasing. If I do a watch, I think I can do a watch. CPU load is increased to 22% because this script is consecutively sending requests to this node port, and on back of this node port, the load is increased to 78%. 78% mean the 500 millicore, whatever we defined, is consumed on one pod. If I show you the pod, kubectl top pod -n dev namespace. So here you can see the request limit. Now another pod is also created. Autoscaling is done. Second pod birth is done. So now the load is distributed. Whatever script is throwing among both of these pods. So now you will see that as the load will increase, it will create the third pod too. So now load is decreased. Why? Because now we have two pods that are entertaining the traffic. Memory is constant because this request that we throw to this deployment is only consuming CPU. Now load is again increasing. Here pod replicas are set to 3. Okay. So now as the third pod is available, it is its CPU is reduced because it is giving the total amount of CPU used by 3 pod. And so now load is distributed to 3 pod. So with this way, this max load will be managed by HPA. We get the top pod. You can see 3 pods are there. We can see it get pods. So auto scaling automatically creating the new or 11 minutes ago, 1 second ago. So when I will stop this script, so you will see the load is consecutively reducing. CPU core usage is reducing. I do get HPA, it's gradually reducing. So there is a timeout value, default values that will take to kill the additional resources. Now CPU is back to 0%. So after some time, if I show you get HPA hyphen OYAML. So here you can see there are some values, default values that are deciding the time taken to create the new pod or delete the old additional pods. It is showing the current value. I don't know exactly where that second value is, but in this manifest we can define those values too. So if I get again the CPU is 3, but still replicas are 3. CPU is 0%, replicas are 3, so after some time it will automatically kill the additional pods. So kubectl get top pod or get pod hyphen w. So we will see after some time the pods are start terminating, and it will be reduced to back to minimum 1. So this was the concept, and we can also create this manifest by using this command line kubectl autoscale deployment and the name of the deployment and amount of CPU limit we want to apply and the minimum pod. But by the command line, we can only do with the CPU. So it's better to use this manifest. In the manifest, you can also apply the memory too. Okay, so we are done for this one. In the next session, we will do some more stuff about we will do in the next session the cron jobs, scheduling of some scripts that will perform some task automatically, just like the cron jobs we have in Linux. So we are done for today. It will take a while to reduce the number of pod.